case time complexity, best case time complexity, and average case time complexity of insertion operation. So did you find it out? What is the time complexity of insertion operation on the data structured array?
Madam, O of n.
Order of
Order of n.
n.
Yes,
Is
for the worst
is
time.
it best case complexity, worst, or
It's the worst case, madam. Worst case.
average case complexity?
Worst. And for the good case, it's for the best case, it's order of 1.
Okay.
When the
For
elements in the
best case,
first
it's
place.
order of 1. And for worst case,
Order of n.
order of n. And what about the average case?
Still order of n.
What is the average case time complexity of insertion operation in array? It's also order of n.
Yes, madam.
It's also order of n. Okay. So we already done how many types of operations on array? 3 types of operation. One is traversal, then insertion, and another is deletion. Right? So when we are using this type of operations on the array, at that time, I mean, which type of array we actually use? We use some one-dimensional array, isn't it? We used one-dimensional array for implementing those operations. So what is one-dimensional array? And here dimension, it refers to the size of the array, isn't it? One-dimensional array is if the array has one dimension, then the array will be called one-dimensional array. Okay, suppose A is an array variable. So if A is one-dimensional array, then how we can declare it? By using only one dimension, right? And here, if the dimension value is 10, that means the size of this array is 10, right? This array variable A consists of how many data elements? 10 elements, isn't it? In one-dimensional array, there is only one dimension. But suppose we are solving some mathematical problem where we are dealing with some rows and columns. That means we are adding or subtracting or doing other mathematical functions on some matrix. What is matrix? Matrix has some rows and columns, right? Suppose A is a matrix where the elements are 2, 3, 4, 5. So in this matrix, the number of row is 2. There are 2 rows. Suppose the row number is 0 and 1. And there are 2 columns, and these are the column numbers 0 and 1. What is the difference between these array variable A and this matrix A? When you took only one dimension, at that time it's actually one-dimensional array. It has only one dimension, and the elements can be easily denoted by one subscript. A0, A1, A2, A3, these are the array elements. And how many subscripts we are using here? Only one subscript. These are the subscripts 0, 1, 2, 3, and the last one will be A9. But what is two-dimensional array? Two-dimensional array means the array will have how many dimensions? 2 dimensions. If we want to store these 4 elements into an array, at that time, we have to declare the variable A as two-dimensional array. That means now the array or this variable A will have how many dimensions? 2 dimensions. Right? These array will have how many dimensions? 2 dimensions. But what will be the size of this 2 dimension?
2 and 2.
2 and 2.
2 and 2, right? Because these A matrix has how many elements? 4 elements. There are 2 rows and 2 columns, right? So this matrix is actually 2 into 2 matrix. So here the number of row will be 2 and the number of column is 2, right? And if we declare this matrix A as 2 into 2 matrix, so maximum how many elements can be stored here? The maximum number of element is row into column, that is 4, right? Suppose we have another array variable and the dimension dimension is a 10, and the second dimension value is also 10. So how many elements can be stored in this array?
100.
100, right? Because here row equals to 10 and column equals to 10. So 10 into 10, that is 100 elements can be stored here. So how we can denote this array element?
By taking row and columns order, like 0 1 0 2 1 0.
Very good. That means now for denoting each of these array element, we need two subscripts. And the first subscript value will always denote to which dimension, row or column, obviously row. So now this element 2 will be denoted by, that means this element 2 is placed in which row? In row number 0, and the column is 0. So it will be 0, 0, right? What about 3? Now we can store this number or this element in which array element? 0, 1. For this data element 3, the row number is 0 and column number is 1, right? And what about 5?
1
The index value will be A, 1, 1. For 5, the index value will be A, 1, 1, right? So what is the main difference between one-dimensional array and two-dimensional array? In one-dimensional array, we have only one dimension, so easily the data elements can be stored in the memory, right? How you can store this data element in memory?
Contiguous way.
This one-dimensional array, so each data element will be stored in some consecutive memory location. If the first data element is stored in memory location 1, the second data element will be stored in the next memory location, that is 2. And the third one will be stored here. If it is one-dimensional array then. Okay? But what about two-dimensional array? Now, this variable A has 2 dimensions, right? And in each of these dimensions, we can see that there are different values are stored here, right? So how we can store these 4 different values in the memory? Which value will be stored first? In one-dimensional array, we can just store the data elements in some sequential memory location, right? So what about two-dimensional array? Suppose this is the memory location. 1, 2, 3, 4. For storing 4 data elements, we need 4 memory location. But which data element will be stored first? Here A00 equals to 2, A01 equals to 3, then A10 equals to 4, and A11 equals to 5. Right? So in row, there are how many elements in row 0? In each of these row, there are 2 elements, or in each of this column, there are 2 elements, right? So how you can store them in this array? Any idea?
Madam, maybe there's 2 array with 2 memory size.
2 array. This is our memory. This is the memory location. This is the memory location, right?
Yes.
So how this element can be stored here? Array is linear data structure, so obviously the element will be stored in some consecutive memory locations. That means if we store one data element in memory location 1, the second data element should be stored in the next. After that, you can place the third element in third memory location, and then the fourth element will be stored here. But my question is, there are 4 data elements and their index value is A00, A01, A10, A11. So which element will be stored first?
A00.
A00, okay. If we store A00 here, then which one will be the second element?
A01.
A01, okay. And then
A10.
A10
and then A11.
So how we are actually storing this data row by row, isn't it? At first we are storing the data element from the first row, and then we are storing the data element from the second row, and that type of memory representation is called row major order. When you are storing the data elements from rows, right? At first we will store all the data elements from row 1, and then from row 2, then row 3, this type of memory allocation is called row major order representation. Okay, but if you want, you can store or you can collect the data elements from column, then you can store them here in the memory. Okay, so another memory representation is called column major order, or you can store the data elements column by column. So at first, the data elements from the first column, that is column 0, will be stored. So here you can store 2 and then 4. After that, the data elements from the second column will be stored here. Okay, 3, 5. So both of these memory representation correct. This is called row major order representation. Okay, and it's called column major order representation. Is it clear?
By default, which one work for this language?
By default, which one?
Like we have a row method and a column method, but when we'll store some data, so by default,
Ashik, what is your question?
like ma'am, when we are storing some value, matrix value, like a two-dimensional value,
Okay.
so by default,
Okay.
which process will follow the language?
Usually they follow row by row
Oh,
pattern or row major order pattern.
ma'am, got it.
Okay, so that is all about array. So from array, how many topics we discussed? Mainly some operations, right? That is traversal, insertion, and deletion. And the last topic was two-dimensional array. But our first topic was what is array and how the array elements can be stored in memory location, right?
Yes, ma'am.
So on data types of operation, isn't it? One is traversal, then insertion, deletion, sorting, merging, searching. But we only discussed about 3 types of operation because we will discuss sorting, searching later. Okay? Operation, that is insertion, deletion, and traversal for all the linear data structures such as array, linked list, then stack, queue. Okay, that means our next data structure will be linked list. Clear?
Yes, ma'am.
So what is linked list? This is another linear data structure, and linear data structure, that means there will be some relationship between the data elements. Just think about the array. In array, suppose we want to store some data items 20, 30, 40, 50. How many data items are here? 5. Okay. If we want to store them in an array, then the process will be just declare an array. At the time of declaration, it will allocate, it will take some space from the memory location. Okay, suppose this is the first memory location, second memory location, third and fourth. Okay. So at first 20 will be stored here. If we are arranging the data in ascending order, descending order, at that time which file will be stored first? In ascending order, 20 will be stored first, and then 30, then 40, and then 50, right? That is array representation. Array is linear data structure, and the data element should be stored in some consecutive memory location, isn't it? That means we cannot skip any of these memory locations. I mean, without filling it up, we cannot store any other element in memory location 3 or 4. That is array. Okay. So if we want to store the same data 20, 30, 40, 50 in a linked list, how we can do it? Because array and linked list both are linear data structure. But what is the main difference between
We need pointer.
linked list and array? The main difference is, in array, we have to store them sequentially in some sequential order, right? But in linked list, it's not necessary that the data element should be stored in some consecutive memory location. In linked list, if the first data item 20 is stored in memory location 1, 30 can be stored in memory location 3 or 4 or any other memory location. Then how we can maintain the linear relationship in linked list? Because linked list is linear data structure. Right? In linked list, it is actually linear collection of data elements, but the data items, they don't need to be stored in some sequential memory location. So how we can maintain that linearity? So in linked list, the linear order will be given by some pointer, right?
Yes, ma'am.
Suppose there, how many data elements are here? 4 data elements. So these are first data elements, and in linked list, we usually consider them as nodes. This is the first node, okay? This is the second node. This is third node. And this is fourth node. And another characteristic of linked list is each node will be divided into 2 parts, right?
Yes,
Each
ma'am.
of this node will be divided into 2 parts. Okay. So suppose the first node here will store 20. Okay. So this is a data portion or data field. In this field, we will store the data. And this is a second node, and here in this field, we will store the second data 30, and then here we can store 40, and this is 50. But still, we don't know actually in which memory location 20, 30, 40, or 50 they are stored. Or we don't know which one is the next value of 20, or which one is actually first data item of this linked list. This is linked list, and each of these nodes has a memory address, right?
Yes, ma'am.
Yes, ma'am.
Yes.
If we consider this as an array, at that time, obviously the memory address of 20 should be 1, 30 should be 2, and 40 will be 3, and the last one will be 4. But it's linked list, that's why we don't need to store them in some sequential memory location. It's not mandatory. Suppose 20 is stored in memory location 1, 30 is stored in memory location 5, 40 is stored in memory location 3, and the address of 50 is 2 and it's 4. These are the address of these nodes 20, 30, 40, and 50. Okay. So if we want to access them, we need to know from where we can start. Which one is actually our first data item here? Which one is the first data element?
20.
20.
20.
Why 20?
Because it's
I already told you one. First data element, they don't, depend on the memory location. Here, 20 is stored in memory location 1. That doesn't mean 20 is the first data item of the list. The first data item can be 30, 40, or 50. It depends on a pointer value. Here in linked list, we use a pointer head, or we can call it top or any other. Okay. So if the value of head is 1, at that time 20 will be the first item of this linked list. Or if the value of this pointer is 5, at that time 30 will be the first data element. So which one is the first data element? It depends on the value of this pointer head. Okay. So here head equals to 1, that means 20 is the first data element. Clear?
Yes, ma'am.
So if it is a first data element now, which one will be the next data element? Because here we cannot use pointer for each of these data nodes. In a linked list, there can be hundreds of thousands of nodes, right? So it's not possible to use a pointer for each of these nodes. So now how we can find out the second data element of this list?
by linking.
So why this node is divided into 2 parts? We already filled up only one field of the node, that is the data part, right? And what about the right portion of this node?
For the
Memory
For
location.
which purpose? For
address.
Address.
yeah,
Memory
so
location.
this portion is
Next.
called link field or next pointer field. So this portion will tell us which one is the next element of 20. So if the pointer value is 5, that means 30 is the next element of the list, because 30 is stored in which memory location? 5,
5.
right? And here, if the value of this pointer field is 2, that means 40 will be the third element of the list, right? And here, if the pointer value is 4, that means 50 is the fourth element of the list. So what about this pointer value? In this list, we
0.
have only 4 elements, right? And we already found our 4 elements, 20, 30, 40, 50. So what will be the value of this?
0.
This is actually, it will contain a null value, null character. That means this is the end of the list. 40 is the last element of the list. So is that clear? What is linked list? The only
Yes,
difference
ma'am.
between linked
Yes,
list
ma'am.
and array is although both of them are linear data structure, but in array the data elements should be stored in sequential memory location, but in linked list they can, or we can start it from anywhere of the list, right? I mean the first data element depends on the value of this pointer head, and each node is divided into two parts, so we can easily find out which one is the next node, right, by using this pointer value. So I hope it's clear to you.
Yes, ma'am.
Okay, so we can point it in this way. Suppose this is our first data element, and this is the second data element, this is third data element, and this is fourth data element. Okay, now the next question is how this data element can be stored in the memory. For one dimensional array, we just needed one. This is one dimensional array, right? That's, we can easily store them in some consecutive memory locations. But what about linked list? Now the linked list is divided into, or each node is divided into two parts. So for storing the data, we need a list, we need one dimensional array, and for storing the second field or the pointer value, we need another one dimensional array. So how the linked list can be stored in the memory, or how this data element can be stored in the linked list. In linked list, there are two parts, right? This is our data part, and this is the next pointer part, next pointer field. So how these nodes 20, 30, 40, and 50, how they can be stored. In array, we just needed one. How many dimensions we need? Only one, right? One. But what about this linked list?
There is two
Two.
dimension.
Very good. So we need two lists, or two. We need two one-dimensional array. So the number of one-dimensional array will be 2. Right? Now we can store them in linked list. These are the data elements 20, 30, 40, and 50. Okay. And what is the memory location of 20? 1. And for 35, for 50 goes 2. Okay.
4.
And what is the value of start? Start equals to 1. For storing this 4 data element in linked list, we need two one-dimensional array. So this is the first one-dimensional array where you can store the data, and the name of this array is data. Okay. And then we need another one-dimensional array for storing the
Data
next pointer field. So suppose the name of this array is next. Okay. And the size of each of these arrays, suppose 10. Okay. So there is also okay, so if the address of the first memory location is 1, then what about the second memory location? These are some one-dimensional array, right? In linked list, each node is divided into two parts. That's why we need two one-dimensional array. This is the first one-dimensional array where we can store the data field, right? And in this one-dimensional array, you can store the pointer field. Okay. So if the size of this data array and next array is 10, then what will be the address of each of these memory locations? The address of the first memory location is 1. What about the second memory location? Obviously 2, because these are some one-dimensional array. Okay, so this third memory location 4, 5, 6, 7, 8, 9, 10. Okay. So the next step is now we can store these 4 data elements to this list. So here start equals to 1. That means in which position we'll store the first data element? In memory location 1. Right? And now look at the node field. In memory location 1, we have a data element 20. So 20 will be stored here. Right? So 20 is our first data element which is stored in memory location 1 because its address is 1. Okay. And from the pointer value of this node is 5. Okay. So that means here we will store 5. 20 is our first data element because start equals to 1. 20 is the first data element, and what is the value of its next pointer field? Each of these nodes is divided into two fields, right? It's the first field, which is the data, and the second field, we know that the pointer value is 5. That means the data element of this memory location, that will be the next data element of the list. So that's why we can store 5 here, isn't it? This is the
Yes, ma'am.
first node, okay, and the second node is 30. And what is the address of the data element 30? The address
5.
is 5, and the pointer value is
2.
2,
2.
right? So where we can store this data element 30?
Index number 5.
The
In
5.
which memory location of this array
5.
data? Very good, 5.
Yep.
Okay, so here the pointer value is 5. That means in memory location 5, we will store the next data element, which is 30. Okay, and its next pointer field value will be stored here 2. Okay,
2.
and now the next data element is 40, which will be stored in which memory location? In memory location 2,
2.
right? So this is the memory location 2, and here we'll store 40, and its pointer field is
4.
it's 40, and its pointer value is 4,
4.
right? So here we can just store the value 4. That means the next data element, that is 50, will be stored where? The next data element will be stored in memory location 4. Okay, so this memory location, and this is the last element of the list. So here we simply can put 0. 0 means this is the end of the list. Okay, so in this way we can store the data elements in linked list. So is that clear?
Yes, ma'am.
So what we have done here, we are just storing some data item in linked list. Okay, so in linked list, each node is divided into two parts. That's why we need two one-dimensional array. This is the first one-dimensional array for storing the first field of the node, and this is the second one-dimensional array where you can store the next field, or second field of the node. Okay, so you can just try another one. Suppose some students name are given, and you have to store them in the array according to their initial letter of the name. Some students name are given, okay, and store the student's name in a linked list according to the initial letter of their name. Can you do it? Okay, I'm just writing the initial letters here. A, then C, E, C. Okay, so how this data elements can be stored in a linked list? How this data element can be stored? If we want to store them alphabetically, that means at first A will be stored, and then C, then E, G, S, Y, right?
Yes, ma'am.
The
Yes,
first
ma'am.
data
Yes,
element
ma'am.
should be A, and then second data element should be C, then E, G, S, Y. But that doesn't mean that A and C, or that doesn't mean they have to be stored in the in some consecutive memory locations. Suppose A is stored in memory location 3, so C can be stored in memory location 1. But the most important thing is the pointer value, how we are creating the relationship between the previous data element and the next data element. Okay, so at first we have to take two one-dimensional array. One is for data and another for pointer. Okay, so this is the array D and this is the array N. So suppose it has 10 memory locations. Okay, and suppose A is stored here and C is stored in this memory location, then E, G, S, Y. Okay, this is a one-dimensional array, and these are the memory location 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what you have to do now, you have to organize them alphabetically, right? So how we can do it? How we can organize the data item alphabetically? Just think about it. And
By pointing
if we want to store them
pointing at
alphabetically, that
ascending
means the pointer value should be, what should be the value of this pointer start? If we want
5.
to, very good,
5.
5. Okay, so we only know, or suppose only one array is given, the data array, and the start value is given. So now you have to fill up the second array. This is the pointer field. You have to find out which one or what should be the next pointer value of for A, for E is. Just try
1.
to fill up the second.
1. 1.
The first data item is A, which is stored in memory location 5, right?
5.
And the second data element C is stored in memory location 1.
1.
That means here in this memory location 5, we have to store 1.
Yes, ma'am.
From this pointer value, we can get to know that our first element, or we'll find out the first element in memory location 5, because start equals to 5, right? So after storing A, now which one will be the next data element? It depends on the pointer value, right? The
C.
next element is C, so that's why we have to create a relationship where between A and C. How we can create the relationship? Just simply write the memory location of C here, right? In the pointer field, we add 1. That means after A, we can store the data element which is in memory location 1. So C will be the next data element, right? After that, the third element is E. So what should be the pointer value for C?
7.
7, right? So 7. So in this memory location 7, we'll find our third data element. Okay? And what is the pointer value of E?
3.
G, because the next data element is G, which is stored in memory location 3, and the next element is S, which is in memory location 8, right? And the last data element is Y, and it is stored in memory location 2.
2.
So Y is our last element. Here we can write 0. So in this way, we can store the data elements in a linked list. Here.
Yes, ma'am.
Okay, so linked list is also a linear data structure. That means the operation, that is insertion, deletion, searching, sorting, can be done on linked list also. Right? So what is insertion operation? Now we can say that in this linked list, the number of available space is 4, because the size of both of these array is 10, but we stored only how many data elements? 6 data elements, right? Now, if we want to insert a new data item, where we can insert it? In a linked list, if we want, we can insert the data element at the beginning of the list, right? And if we want, we can insert it at the end of the list, or we can insert it between 2 data elements. We can perform the insertion operation in how many places? 3 places. One is we can insert a new data item, and we can make it the first data item of the list. And then we can insert a data item as the last item of the list. And another is, suppose between A and E, we can insert a data item, suppose B or D, right? So if we want to insert a data item at the beginning of the list, that means now after inserting a new item, suppose we want to store item B, okay, and we want to make it the first item. At that time, the value of this start pointer should be changed. So how you can do it? If the new item will be inserted as the first item of the list, at first we have to insert it, and then the value of start should be changed. So what is the process? placing the new item in the array as the first item of the, first item of the list.
And do you have to remove A?
Sorry, we have to
Remove A.
we have to, okay, suppose this is not A, this is B. Okay, if it is B,
Okay.
and now we want to insert A. And another thing, this list can be sorted or the list can be unsorted. Okay, so
Madam, can I
since we are
make
using a
that A
sorted
as a
list, so let's
head?
assume that now we want to insert A. Sorry,
A as a head. To insert A, can I do? Can I make that A as a head of this linked list?
A will be the head of the linked list.
To insert it, as there's no
A is a data item, right? And here in this pointer value, we can store the position, we can store the memory location, right?
yes. Then
And
location
look
of
at this,
A,
in
madam.
this array, we can see that some, in which position you can find some empty spaces or some available spaces in memory location 4, in memory location 6, 9 and 10. Right? In insertion operation, at first we have to find out an available space. But there are 4 available spaces, so which one should be assumed as the first available space?
4.
4.
Why 4? This is linked list, so it doesn't, we found the first available space in memory location 4. That doesn't mean that it always needs to be the first available space. If we want, we can make 9 as a first available space or 10 as a first available space. It's possible. That means we don't know which one among those 4 available spaces, which one is the first available space. So how we can decide it? Obviously by using another pointer variable just like start. In this array, we have 4 available space, but we don't know which one is the first available space. That's why we can use another pointer value, and the name of that pointer is avail. That is a short form of available. And if I say that the value of avail is 6, that means 6 is the first available space, right? 6 is the first available space. Now, again, we have to create some link between those available spaces. If 6 is the first available space, then which one will be the next available space?
We don't know.
9.
We don't
9.
know, right? So that's why we can create some relationship here. Suppose the pointer here in this field, the value is 4. That means 4 is the second available space. From this pointer value, we can see that 6 is the first available space, right? And in the second portion of this node, we have placed another value that is 4, which means 4 is the second available space. Okay? And if I add 9 here, that means 9 is the third available space.
Third available
and
space.
10 is the fourth
10 is the
available
last.
space. Now here we can place another 0 for denoting the end of the available, end of the available space in that list. Is that clear? In insertion operation, at first we have to find out whether the list has some empty space, available spaces or not. Okay? And if the list has multiple number of available spaces, then we need to decide which one is the first available space. Okay? And from where you can get to know it? From these pointer value available, from this pointer available. Okay? And now the value is 6. That means 6 is the first available space. That means we have to insert the new item here. If 6 is the first available space, we cannot insert A in memory location 4, 9 or 10. Here we can only insert it in the first available space. Okay? So since we are using another pointer variable here, now we have to create some relationship among those empty spaces. So just add a value here. Suppose here we have added a pointer value 4, which means 4 is the next available space, and then third available space is 9, and the last one is 10. right?
Yes, ma'am.
Okay, so for inserting or before inserting any new item, we have to create the algorithm. We are inserting a new item in a list and we want to make it the first data item of that list, which means after inserting the data item, we have to change the start variable also, the value of start variable also. Okay, so how many parameters we need in this operation, in this insertion operation? For inserting a new item A in the beginning of the list, how many parameters we need?
Item, position.
Sorry?
Ma'am, item and position.
Item, okay. We need to know about the item.
Position.
And empty
Suppose
space.
item equals to A.
And the position.
Okay, we need to know about the position. That means the inserted position, right? Where we are going to insert the data item, the position, and then
Empty spaces.
Array.
empty spaces. But we are using a variable for denoting the empty spaces, that is avail. So we need to use avail in the algorithm also. We need to use avail and we have to use these two array also. One is data and another is next. So can I just clean the board for writing the algorithm?
Yes, ma'am.
Okay. So we want to insert a data item where? At the beginning of the list. Or insert A at the beginning of the list. Okay, so what is the first step of this algorithm? Just try to create it. We know the steps, right? If it is our array, that is data, and another array is next. Okay, so there are some spaces. How many data we have? Suppose we have only 3 data, okay, and the data are B and then G, and another data item is I. Or we can take another one, P. So in these array, how many data items we inserted or stored? 5 data items, sorry, 4. Just create the link. If B is the first data item here, that means the value of start will be
3.
2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So in this array, the first data element will be 3 because this pointer has a value 3. Right? So B is the first data element, and which one is the next second data element?
6,
6, right? So here the value will be 6, and
8,
we can
8.
find the data element here, so it will be 8, and here we can write 1.
1.
This is I. Okay, and now we want to insert A where? In the beginning of the list. That means after inserting it, now we can make it the first data element of the list. So in insertion operation, we need another variable that is called avail. Okay, so how many available spaces are here? 6 available spaces, right? And we can assume 7 as our first available space. So here the value will be 7. So 7 is the first available space, and then the next one is 2, then 9, okay? After that 4, and then 10, and the last one is 5. Is that clear? So what is the sequence of the available spaces now? Which one is the first available space? 7, right? And then the
7.
next available space is 2,
2,
After that 9,
9,
and then 4,
4,
then 10, and the last one is 5,
5.
right? And we want to insert a, where we can insert it in the first available space. So here the first available space is 7. That means we have to insert a here, and after that we have to make it the first data item. That means this value should be changed. The new value of start should be 7. So how we can do it? After the insertion operation, now the first data element will be A, and we can find it in which memory location? 7. So that's why we have to change the start value. Now start equals to 7, right? And then which one will be the next data element? We have to change this value also. So from where we can start? What is the first step of the algorithm? Obviously, we need to find out the available space, right? We need to find out the available space, then we can define it here that the first or the item will be inserted in the first available space. Where are we going to insert the data element? We will insert it where? At data available. Where will insert it? At data avail, right? That means data avail equals to A. Here data avail equals to A, and what about the memory location of that data item A?
7.
7.
7. That means next avail equals to, next is the name of this array, right? Equals to 7. So this is the place, or this is the item that we want to insert. Where we will
In 7.
insert it? In the first available space. So that is our first step in the algorithm, that is insert at data avail. So what will be the next step?
Change the start.
Change the
start value.
When we define this step in the algorithm, that is insert at data avail, did you actually insert the data element in memory location 7?
Yes, ma'am.
Yes, ma'am.
What is the meaning of this step? What is the meaning of step 1? Insert at data avail. What does it mean?
We are storing data on a 7 address.
We will insert A in 7 memory location.
Sorry, it means?
It means
We will insert
What does it mean?
filling the
Insert
empty
at
space,
data avail. What will be the output of this line? From this line, which thing or what will get?
the empty
Inserted
space
data
will be
avail. Data is the name of the array, right? And here the value of avail is 7.
Madam, empty
What will
space
be the output of
We will put the element in
this
7th
statement?
memory
Insert
location.
at data avail. That means insert at memory location 7. Here data
Yes, ma'am.
avail equals to 7, right? That means we will insert the data item here.
Yes, ma'am.
Okay, so here we are just identifying the memory location where we can insert the new data item A. Okay, after that the next step will be, now we can
link with
write
other.
set link.
Ma'am, we have to change the
Linking with the
value of
next
start.
uh,
We'll remove
with the
3.
next node.
If we take the first available space, suppose the first available space is 7, and if we insert a data item A, that means 7 is not an available space now, isn't it?
Yes,
After inserting a data item in the first available space, that is 7, now this is not the available space of the list, isn't it?
Yes, ma'am.
So
Yes,
now
ma'am.
after that, now we have to change the value of this variable. What will be the value of avail now? when we insert a new data item, at the first available space 7 now, the next available space is 2, it will become
2.
the first available space of this linked list, isn't it?
Yes, ma'am.
Yes, ma'am.
So how we can write that statement in the algorithm? In the first step here, we have declared that, we have stated that the data item A can be inserted in the first available space, that is 7, right? So after that, now 7 is not an empty space. This memory location has a data item A, right? So now we need to change the value of this variable avail. How we can do it? Can we just write set avail equals to next avail? Can you write it?
Yes, ma'am.
Set avail equals to next avail. The first available space was 7, right? That means data avail, it means the memory location 7, right? This data avail equals to 7. What about next avail? Next is the name of this array, right? What is the value of next avail?
2.
2.
2, right? So if data avail equals to 7, that means next avail equals to 2. So it will be the first available space now. Here we can assign the next avail as the value of the variable avail. That means the new value of avail will be 2. Is that clear?
Yes, ma'am.
After inserting a new data item in the first available space, now we have to change the value of this pointer avail. Okay? 7 was the first available space, but now we inserted the data item A. That means the second available space 2 was the second available space. It will become the first available space of the linked list. Is that clear?
Yes, ma'am.
Okay. Now our next step will be, after changing the value of this pointer avail, now we have to change the value of start variable or start pointer. So how we can change it?
Start equal data avail.
Start equals to
Data avail.
Did you skip any step here? Did you skip a step here? Because look at this. When we inserted a data item here, we didn't change this field. We didn't change the value of this field, right?
Yes,
What
ma'am.
is the first step? The first step was
Yeah.
insert at data avail. So actually the next step should be set inserted position equals to avail. If we write set inserted position for position equals to avail, what does that mean? It will not
Start will be 7.
right. Yeah, it's the same thing. So actually, if we skip this statement, it will not affect the algorithm, right?
Yes, ma'am.
So how we can actually modify it? How we can modify the value of start variable? Now the value of start is 3. How we can change it? Can we just write set next is the name of the array, next position equals to start. Can you write it?
Set next position.
Set next position equals to start. Our inserted position equals to avail, right? What is the value of position? Position equals to 7, isn't it? This is the position where we can insert the data item. After that, can we make it next position, that means 2. I can change it. Hello, can you hear me?
Yes, ma'am.
Hello?
Yes, ma'am, we can hear you.
Yes, ma'am.
Yes. So this is our next step. Set next position equals to start. What does that mean? We have already made the position value as a, I mean, this is our available value, right? Available equals to 7. That means here position equals to 7. Position
Yes,
equals to 7.
7.
And in that position, we inserted the data item A. Now we want to change the value of the pointer start. How we can do it? If the next statement is set next position equals to start, how we can interpret it?
So now start will be 7.
Very good. So now start will be 7, isn't it?
Yes, ma'am.
Set start equals to, what will be the next statement? Set start equals to inserted position, and our inserted position was 7. That value will be assigned to the pointer start. So that is the algorithm. What we have done here, we just wrote this algorithm for inserting a new data item in the beginning of the array. So the first thing is find out the first available space. Okay, and that space will be our inserted position. The position where we can insert the new data item. So after inserting the new data item, now we have to change the value of this available, this pointer available. Okay, so initially these two, that was the second data or available space of the linked list, which will become the first available space of the linked list, right? So after
ma'am.
changing the value of this avail pointer, now we can change the value of start pointer. How we can change it? Now we can just follow the last step, that is set start equals to inserted position. Just make the value of inserted position as the value of start variable. So 7, that was our inserted position, and now it has become the value of start variable. Is that clear? Or we'll again discuss this algorithm in our next class. Okay?
Okay, ma'am. Okay, ma'am.
Please respond. 1,
Yes, ma'am.
1, 2.